It is 6 p.m. We should be live, which means that I can say hello, everyone, and welcome to the Object-Oriented Programming Workshop. Could you please let me know in the chat if you can hear me, if you can see me, and I have my fan on because it's incredibly hot in my room. So also, please leave a comment to let me know if you can hear the fan, if it's good, and if not, I'll turn it off, and I'll try to survive over here. So yeah, again, welcome. My name is Sven. Most of you probably won't know me. I was a OOPTA last year and a few years before, which is actually quite a good segue into what I want to do today. So during my years as a TA, I've seen quite a lot of exams. I can see that everything's perfect. Great. I've seen quite a lot of exams in the past couple of years, and most of these exams had somewhat similar structures in terms of what questions were asked, the way they asked the questions, but most importantly for you, the way that the teachers grade the exams. Because thing that you may not know is that the TAs grade the exams alongside the teachers. So what I want to do today is I want to go through the different topics that I see a lot at the exams, or that I have seen a lot at the exams. I want to show a few example questions, and then also show the solutions, plus essentially tell you the way that we were supposed to grade them, hopefully so that can help you in order to prepare and make the most out of it. One side note, and I'll show this again later, but when I'm also going to do exam questions, I can imagine that there are people who want to do the exam questions later. So what I'm going to do is whenever I'm showing the solutions of an exam question, I'll show this warning sign that you should be able to see in the top left-hand corner. If someone could let me know if you can see the warning sign, that would be great. And then when I'm done with the question, I'll remove it again so that the people who want to do the questions and not hear the solutions from me know, okay, we can do it, or now we can go back to the presentation. Anyway, without further ado, let's get into the topics. So first we're going to start off with the absolute basics, the things that should be doable for everyone. Then we're going to go into generics, design patterns, very briefly, JavaFX, concurrency, and then at point 6 it says exam questions, but it's mostly questions also from you. I could do some exam questions. I have my IDE fired up and ready to go. I have my notepad over here, so if there are small questions, I'll answer them on the spot. If there are big questions, I'll save them for later, and for the people who want to have the answers or want to have the answers to those questions and see me do a bit of programming, stick to the end, and we'll get it together. At some point, I'm probably gonna opt to do like a mid-section Q&A/break for the people who want it. Anyway, you'll see how it goes. This is a somewhat new thing for me as well with the live streaming and stuff, so we're just gonna go with the flow. So let's start off with the basics. So obviously, object-oriented programming, classes. This is absolute very basics, just to make sure that we're on the same terms with the terminology that I use, plus the terminology that you are used to hearing. We have a class person. A class has things that we call attributes, attributes being the things that sort of identify a class or give a class its significant meaning. The attributes that are being set in a constructor, constructor being, again, the object that sets the attributes and is basically used to initialize the class. And a class has functions that can be called from outside the class. Important thing is attributes can never ever be public. First thing where I deducted many points from during grading the exams, people who leave their attributes public. Have them either private or protected unless the assignment states otherwise. Your functions can most of the time be public. Just leave them public, it's the safe way out. So what do you do when you have a class? You declare it. So before we saw the class person. So at the bottom left of your screen, you see person P. That is called declaring. At this point, the P has a value of null, N-U-L-L. So most of you probably have seen null pointer exceptions. That would happen if you would, for example, call p.getName, which you can see in the bottom right-hand corner, without initializing a class. So when it still has a null value, you call a function that ends up in a null pointer exception. So what you always have to do is initialize a class, and that you can see in the middle part, and that is the part where you say p is new, in this case person, and give it the values that it has. So how does that work, and what is the path of the variables, essentially? We say person P is new person, Sven, 25, 1, 2, 3. So the 25 is the age, and the 1, 2, 3 is the ID. So those go into the constructor, essentially. You can see that that's the same variable layout that you see in the constructor, right? String int, int. Then they go through the constructor and are being set in the attributes. This is a thing where a lot of questions come in, is when do you use this dot? You use this dot name, in this case, if the parameters that are being passed in have the same name as the attributes, right? So you see that the attributes have the names name, age, and ID. Now what you can see is that it says public person, string name, int age, int ID. So there's a naming conflict with the attributes and the parameters. So what you then do is you say this dot name to indicate that that's the value that you want to, or that's the attribute of the class. So you say this dot name, the attribute is being assigned the value of name, the one that comes in through the parameters. Imagine that instead of string name, we would have called it string n. In that case, it would not have been necessary to add this dot because there's not a naming conflict. Not that important, but something that I get a lot of questions about. So from there we go to interfaces and inheritance. So interfaces and inheritance, that's the thing that you've seen with the implements and the extends. Question that we get a lot is, what is the difference between interfaces and inheritance, and what do you use it for? Now, let's say that we have classes that are similar, but not like right out copies of each other. So for example, we have people, we call them person, and we have two types of person. We have students, we have teachers. They're both students, or sorry, they're both people. They all have like a name, they all have an age, they all have an ID, but they're slightly different in how we use them. So that's essentially a way to use interfaces and inheritance. You make an interface or an abstract class that will be person, and then then you make children of that for students and teachers. Now, what's the difference between interfaces and inheritance? Inheritance, the entire thing is called inheritance, but what I mean is essentially abstract classes and then extending something. Interfaces, they can only have functions, and they don't have attributes, and they don't have function bodies. Sort of. There are exceptions, just assume that they don't have function bodies. So you cannot already implement a function. You can implement multiple interfaces, but you can only extend one class. So what are abstract classes, or what do you have with inheritance? Well, those classes, the abstract classes, they can have attributes. They have a constructor, they can have function bodies, and they can also have functions that are not yet defined, and those are abstract functions, and those are the functions that you have to implement in the children. Now let's just jump into an example, because I think that's a lot easier. So we have the same class person that we had before, except this time we made it abstract. What you may also notice, and which it also says, is that the attributes are now protected. Protected means essentially that the attributes are available to this class and to the children classes. So let's say that we have a class person, which is the abstract class, and then a class student, which is its child. Student now also has access to the name, age, and ID. We can set name, age, and ID through the constructor, just as we did before. But let's say that we want to have a method string or toString and a method work in the children classes, we can make those abstract, and now we have to implement them in all the classes that extend person. And one final thing is the entire class is abstract because it has abstract functions. A class doesn't have to be, even if you use inheritance or if you plan on using inheritance, a class doesn't have to be abstract if it doesn't have any abstract functions, but it's good practice to always do so. So if you know that you have to make or have to use inheritance, make sure that your parent classes are abstract. So now we go into the children class, or the child class, I should say, student. Now this is an interesting thing. We see the super part, and I'll get back to that in a little bit. And here you see that it also has the toString and the work, which are the classes that it inherited from its parent. But now, what is that super statement exactly? I see that there are a few. I see that there are a few questions coming in. I'll address those in a second. So let's say that we have a student class which extends a person class. So now when we say student S is new student Sven, 24, I see my age is different here, and 1, 2, 3, those come in through the constructor of student. Then they're going into the super method. The super method passes them on to the constructor of its parent class, so person, and then person assigns them to the attributes. So that's essentially the path of the variables that we have here, and that's what the super command means. What does the keyword abstract exactly mean? It's more of an implication that it has. When a class is abstract, you cannot create an instance of the class because it's an abstract class. Like, it's not a clearly defined class. So I can now not say person P is new person because person is abstract. That's essentially the meaning. And I also see multiple inheritance is not allowed in Java. Sort of true. What you can do in interfaces, if you create an interface, you can extend other interfaces. And that way you do have multiple inheritance. Oh, sorry, with multiple inheritance. No, yeah, no, exactly. Multiple inheritance is not allowed in Java. Sorry, I thought you said multiple interfaces. So, excuse me, you're right. Multiple inheritance is not allowed in Java, but it is indeed allowed in some other programming languages. My bad. So now to the interfaces. This is an interface that you've seen before, and I think it was in assignment 3 or something like that with your geometric shapes. So you had to create like circles and rectangles and something like that. The comparable class allows you to sort a list of that class. Now, what do I mean with that? Let's say that I have 5 people standing in a row, and I look up to you and I walk up to you and I tell you, hey, I want you to sort these people. And you're probably going to ask me, sure, I would love to, but how? Like, what's your sorting criteria? That's something that you define using the comparable interface. So in your comparable interface, you get the compare to method. The comparable interface, by the way, is a standard interface that's already built into Java. So you get the compare to function. And what you can do in this function is you can basically specify how you want to compare two people. So in this case, it's based on age. So generally how comparisons in Java work is that if the two values are equal, you return a 0. If one's lesser, or if one's bigger than the other, you return something below 0, generally -1. And if the other one is bigger, you return something higher than 0, larger than 0. Generally, that's 1. And that's exactly what this integer.compare method does as well. I could have also written if age is lesser than o.age, then return this, else this integer.compare is essentially a cheat code for that. So how does this work? Let's say we create a list with 3 people, Sven, Bob, and Peter. So first, if we print them, we have, well, the same order that we put it in the list as. Then we call the erase.sort method, and we give the peeps, the person list, to the erase.sort. We print it again, and now you can see that it's sorted by age versus Bob, then Sven, then Peter. So from interfaces, we're going to jump into lambda expressions because those two are actually related together quite closely. I've seen a lot of exam questions with those being related as well. We're going to jump into one in a little bit. And it's just something that's good to see. So what I told you before is, right, with the list of people that you have to sort, you can use the comparable interface. And as you can see over here, the comparable interface is put into the person class. I see the comparable interface essentially as a default method of sorting things. So let's say that we have person. The default way of sorting people is by age. Now let's say that we want to sort them just once in a different way, using basically a custom way, and we want to sort them by ID instead of by age. In that case, we're going to have to use a comparator. That's also something that you should have seen in assignment 3. Now, I don't think comparable and comparator will be at the exam, but it's still good to understand how they work. So what you can do then is you can create a class that implements the comparator interface. Make sure that if you implement comparator, that you essentially tell the class what you want to compare, in this case, person. And then you get essentially a similar compare method. Now you get 2 persons as parameters, and it has the same structure where you have to return something lower than 0, 0, or something larger than 0, depending on which one's bigger. And now you can also see, as opposed to the previous slide, that in arrays.sort, you're not only giving in peeps the list of person, but you're also passing in the ID comparator, basically saying, hey, I don't want you to use the default sorting method, but I want you to use this custom ID comparator. Now, what we can also do, option 1, was the external class. So, right, so we create an entire standalone class ID comparator that only focuses on that comparator. What we can also do is put it in something that's called an anonymous class, which is essentially a local class that you could put into the function. So you can see it still calls the arrays.sort. It gives in the list, but then it gives in this anonymous class. Generally not the best, it's not necessarily bad practice, but something that you just don't see a lot. I just wanted to show you that it exists for this particular reason, because it builds up to the lambda expression. Now this is a lambda expression, and I want you to look at the similarities between the lambda expression and the anonymous class, right? So first, if you look at the resemblance between the external class and the anonymous class, they're essentially exactly the same, right? They both have a compare function that's implemented in exactly the same way. Now, if you look at the anonymous class versus the lambda expression, what you see is that it also has that same layout. So on the right, you see person 01, person 02. Those are essentially the parameters, or those are the parameters, and those you put before the arrow in the lambda expression. Then it returns integer.compare 01.getID, 02.getID, that you put after the arrow. What you may note is that I don't say return integer.compare on the left-hand side. That is correct. If there's only one line of code after the arrow, you don't have to add the return statement. If you need multiple lines of code, you need to add square, like those curly brackets that you see over here. You need to add those, then you can have multiple lines of code within the lambda expression, and then you have to add the return statement as well. If this is unclear, please let me know, then I'll add it to the to-do list for things that I want to show you at the end. Next part, and I think the last part of basically the basics, are iterators. Iterators are essentially a different way to loop through lists. And why is that useful? Now let's say that we are looping through a list, but sometimes we will have to remove elements from that list. Now that will probably become a nightmare with indexing, right? So if I'm in a for loop and I remove an element, then the length of the list, the size of the list, is going to reduce, right? So my for loop is going to break because it still thinks that the size of the list is the old size that it started out with. So you're probably going to end up with like a array index out of bounds, or like invalid list entry error, something like that. If you want to then access an element from the list that's not in there anymore because something was removed. That's what you use iterators for. So iterators allow you to loop through a list and remove elements from that list without essentially destroying your iterator. You can still properly iterate through the list. Iterators have three functions, and I'll show you an example of how it works in a bit. It has three functions, the hasNext. So an iterator is essentially a to-do list or a queue of elements that you want to inspect. The hasNext checks if there is an element still left to explore. The next function grabs the first element that's in the queue, takes it out of the queue, and that's essentially the element that you're currently exploring. So you should always put that element into a variable. Again, I'll show you in a little bit. And then the remove function removes the function that you are currently exploring from the original list. So that's an important thing. It removes it from the original list. I saw a question, why can't you implement both comparable and a comparator interface in the same class and override both the compare and compare to? So yeah, why can't you implement both the comparable and the comparator interface in the same class and override both the compare and compare to function? Honestly, maybe you can. I've never tried it. It's also not the best of practice because like the comparator is like a very, it's designed to be a custom sort function, right? So you don't want to have your custom sort function. It would be kind of weird if something that's specifically designed for sorting is already in the class person, right? So like a default way of sorting, sure, but a custom way of sorting is a bit weird. That's not good OO practice because it doesn't really belong in that class. Sorta does. It's like one of those edge cases. Maybe you can. Nice. Would be a fun one to try. Anyway, back to the iterators. So we still have that same list of persons. Oh, note by the way that I use the peeps.addAll to add the elements to the list. If you want to add the elements one by one, that's fine. You don't need to know the add all notation. So first I add everyone to the list, and then I create an iterator. So I create the iterator on the specific list. Also notice that the iterator is of the same type person as the list is, because it's looping through that list. And what you can always do with iterators is you can have that while loop while iter.hasNext. So that's the hasNext function that I mentioned. And in the first line of the while statement, you can have person p, person, of course, being the type that the list is of, is iter.next. That's essentially always the same layout that you have with iterators when you're using an iterator. And then after that, you can do whatever needs to be done in the function. So in this case, I removed everyone that was younger than 23. So I said if p.getAge is lesser than 23, iter.remove. And then you see if I print out peeps, that it removed Bob, because Bob was the only one younger than 21 and cannot be in the list anymore. Okay, that is it for the basics, which means that I'm going to take a sip of my drink, and that means that we're going to jump into generics. Unless there are any questions, but then I'll see them come in as we go. Generics, also always a very tough one to explain conceptually, because it's quite difficult conceptually. There was something with modifying the list using, that's a question, there was something with modifying the list while using iterator. Can you explain it? Well, essentially the one thing that I want to stress, if I understand you correctly, is that you can see here in the while statement that I want to remove people from the original list of people if they are younger than 23. So if they are younger than 23, I don't want to have them in the list peeps anymore. That is a list modification, right? Because I'm removing them from the list. And then you can see in the if statement in the while loop, I say iter.remove. So essentially that removes it from the original list peeps. So I think that's the modifying the list, what you mean, because that iter.remove modifies the original list by removing that element from the list. And it does it safely because it's an iterator, so you don't have index problems. If I'm explaining something wrong, please let me know in the comments. So now going into generics. Generics essentially mean that you're going to have a variable or a list of variables, right? But you don't know what that variable is exactly. You can have either generic functions and generic classes, and I think it's just easiest if I explain. But first, you've seen generics before. You've used them a lot. Lists, for example. Lists can hold any type of element. You can make lists of strings, lists of integers, lists of persons, for example. So lists are generic, right? So everything where you see the diamond brackets, those are generics. It has not been specified yet what will be in the list or what type will be in the list, but it's available, or like every type is available to go into the list. Another example is the hash map, which you've seen in one of the assignments, a hash set, and a comparator interface that we've seen before. So what does a generic class look like? How do you make a class generic? Now let's say that we want to create a generic class pair that holds two values, an x and a y, and they can be of any type. So what you do is at the top of the class, like after pair, you put the diamond brackets and you put the variable names that you want to use them as. So I'm putting x and y. You can put in whatever. If you want to call them cookie and banana, that's fine. That works as well. So those are just essentially placeholder names. From that point onwards, x and y are variables that you can use throughout the entire class. So now you can create attributes, for example, for x and y. It works because at the top we specified that x and y are now that they are now valid variables or valid types. So we can use them throughout the class. We can add them in a constructor. We can make getters and setters from them, and we can just use them in the class as much as possible. Because, for example, we cannot call specific functions of x and y because we don't know what type they are yet. But we can use them within the class. I can see the comment. It was about an error, the concurrent modification exception. Don't know the concurrent modification exception. I'm also going to point out I am I would consider myself somewhat of an expert about OOP, the course, by now after being TA for a couple of years. I'm not a Java expert at all. So like there are a lot of Java things that I don't know, but that kind of also means that you don't really need to know it at the exam. So won't be able to answer your question. I'm sorry. Won't be important at the exam, I would assume. Anyway, so we have the generic class here. How we would use the generic class is pair, then you, just as you are used to with a list, for example, define what the input or the x and y types are, string, integer, and then you define and initialize the rest of the class just how you're used to. And now you see, by the way, also that the high and the 1 to 3 have to match the type that the generic class is of. So they have to match string and integer. That's it for the generic class. Now let's jump into the generic function. And for this example, I looked at, let's say that we have a list of elements and we want to have a function that returns the first element of the list. Not a very special function, but it has to work for every list. So it has to be a generic function because we don't know what the input list will be or what type the input list will be of, but we know that the function has to be able to return the first element of the list regardless of the type of list that it is. So I say public because it's a function. Now I add the t in diamond brackets. That t means this function is a generic function, so it's going to return some type. We don't know what type yet. Then we're going to specify, okay, what will the function return? So this is, with a generic function, most of the time going to be a list of t or just going to be a t. Also note, by the way, it can be t, it can be s, it can be cookie. It's whatever you decide to name it. So it returns a single element t because I want to return the first element of the list, which is just one element. It has the name, head of list, and it has an input. And what is important with a generic function is that the generic type t depends on the input parameters that it has. So in this case, it gets a list of t, which is the input. That t is basically the t that determines every other t. That's a lot of t. I hope this is clear. So what I can now do is say t head is input that gets 0. T head, t is now a valid parameter in this function. So we can say t head is input that gets 0, and then we can return that. That's essentially it for the generic functions. So is it always necessary to put something in the diamond brackets? Because for array lists, for example, you can also say array list is new array list without diamond brackets. Yes, essentially it is always necessary to put, I would say remember for now that it's always necessary to put something in the diamond brackets of an array list, especially before the is sign. So for example, if you say array list and then define the type list is new array list, then after the is new array list, you don't have to put something in the diamond brackets because it's going to assume that it's the same type that you put into the diamond brackets before the is sign. But yeah, it's a bit deeper than that, but just assume for now that you have to always put something into the diamond brackets. And then also a question, what did the first t refer to? So the first t in this generic function basically says this is a generic function. That's what the t means. So that t means this is a generic function, and the second t is this generic function returns t. So yeah, and I can use that, for example, in this manner. I can say, I can create a list of integers, and I can say system.out.println head of list input. So basically that's going to print the number 1 because it returns the first element of the list. Okay, this is going into all exam question territory, but not necessarily yet. So I also want to make like a quick remark at this question. What I see a lot is that when people dive into exam questions, they read the entire question and just start messing around and programming. That works for some people, definitely doesn't work for everyone. So I picked here one of the hardest exam questions in terms of what we saw people scoring the points at the exam. So this was one of the worst made exam questions in the past couple of years. And that's mostly because there's just a lot of information in the question. What I want to do is basically show you how I break down such an exam question. And what I also want to tell you is how I approach exam questions in general, which is essentially write down a sort of like cookbook recipe for yourself. So for what do I mean by that? What I mean is that you read the text and break. First, you have to ask yourself the question: what does this function or class or whatever? What does it have to do? Second question is, okay, how can I break what it has to do? How can I break that down into smaller steps? How can I break those steps down into smaller steps? How can I break those steps down into smaller steps? And repeat that process until you essentially have pseudocode for yourself. Because that pseudocode you can then implement, and sometimes you will even get points for the pseudocode if you don't know how to replace that pseudocode by actual Java code. So that's just something that I want to stress, is really break texts down point by point and see how you have to implement it. And I did that a little bit over here. I'm going to show you how I did that with this text, so how I broke it down. Then I'll put up the warning sign to show you, hey, I'm going to show you the code for it now, and then in a little bit, yeah, we're going to continue with the rest. So I'm going to read the question very quickly. Predicate is an interface designed in java.util.function. In this assignment, you can assume the following definition. See the code. The actual interface contains some static and default methods that are not used here. Define a class filter with a static generic method filter that gets both a predicate and a list of elements as arguments. The elements of the list that do not match the given predicate are removed from the list. These elements are collected in a list returned by filter. When the input list is an array list, the result should also be an array list. Otherwise, the result should be a linked list, and use an iterator in your solution. Mouthful. First things first, what do they mean with predicate for the people of you who didn't catch it yet? So what they mean with predicate is essentially a true or false statement, or true or false condition. So for example, a predicate would be younger than 30. And then if I would apply myself to that predicate, the predicate would basically be false because I am younger than 30. Then it would be true because I am younger than 30. Now, how do I break this down into small steps? Essentially, line by line. So it says define a class filter. Perfect. I create a class filter. Easy. And that's something that I also would write down. Create a class filter. You have, like, you're on a computer. You have like unlimited typing space. Just type these kind of things down. Create a class filter with a static generic method filter. Okay, perfect. The method needs to be static and it needs to be generic. Something that you can just learn, something that you can write in your cheat sheet, something that should not be a problem. That gets both a predicate and a list of elements as arguments. Okay, perfect. So there are two arguments, predicate and a list of elements. And these determine the generic type T. So for example, if the parameter list is a list of integers, then T will be an integer as well. The elements that do not match the given predicate are removed from the list. Okay, so that means that we need an if statement that needs to check the predicate and possibly remove items. These elements are collected in a list returned by filter. We need to create a list in a function that we can store the elements in that do not match the given predicate. And now we also know what the return type of the function is. We know that it returns a list of T. When the input list is an array list, the result should also be an array list. Okay, noticed. Now we know what to do with creating the list that we return with the function. And then lastly, use an iterator in your solution. Use an iterator to loop through the list that was given as an input parameter, which also makes sense because we have to remove elements from that input list. Okay, this is the part where I'll put up the warning sign. I will do this question and the question that followed at the exam, but that's quite a short question, so I'll just leave the warning sign at the top. Okay, should be there. People have a little bit of time to cover their screen or throw their laptops out of the room, and let's go. So first I created then these 5 steps, which are essentially created by writing down those things that I highlighted in the text. The slides will also be shared later, so you'll be able to see these steps later. First, we start with the skeleton, right? So we know that it's a public static generic function. So we can start with the public static T in diamond brackets. And then we know that it's a generic function. Well, we know the return type, it's a list of T, and we know the name, which is filter. We also know that it has 2 input types, predicate of T pred, I call it here, and a list of T input. That thing with predicate T pred is something that I derived from the page before, where they gave the definition of predicate. Now, we know that we need to return a list, and we know how it needs to be created, as in we know that if the input list is an array list, then the return type is an array list as well. Otherwise, it's a linked list. We can do that here using the instance of method. Next, we know that we need to use an iterator to loop through the list, so we can create the iterator, which is again of type T, because everything here is of type T, and we can make that essentially default thing that we do with iterators. So the while iter.hasNext, and first thing in the while loop is the TT is iter.next, and then we can do the if statement. If it does not match the predicate, it adds it to the output, and we call iter.remove. There we go. That's the function. Now, and essentially how they would do it with points, I think it was something like, if you do the generics correctly, you'll get 2 points. If you do the iterator with the while loop correctly, that's 3 points, and I think that the remaining 3 points or something like that was basically for other errors in the code. So that basically means that if you just do the generics correctly, basically make the generic function correctly, already get 2 points. If you have the while loop with the iterator, or if you create the iterator correctly, you have the while iter.hasNext, and you have the tt is iter.next, you get another 3 points. That means that you can have 5 points already without writing any proper code. So I think that at the exams in general, you can pass with like an 8 or something without writing any functional ORM working code. Maybe fun to know. I see a question. We're not allowed scrap paper during the exam. Do you perchance know if we can take notes in some other way? I do not, but that sucks. Like the last couple of years, I think that they will then give you some notes, but I'm not sure. And why do you, that we call remove here? It seems like neither does it change anything in the output list nor time complexity. So it definitely does change something in the output. Oh, it doesn't change anything in the output list. So yeah, in the function description, it specifies the elements in the list that do not match the given predicate are removed from the list. So that's why it says in the assignment that you have to remove them from the input list. So that's why. Okay, and the rest is all about cheat sheets. I'll tend to that later. Then to the next question. Define a method main added to the filter class that uses filter to print all odd numbers from the list containing 1, 2, 3, 4, 5. Use a lambda expression to specify the predicate. Okay. Can sort of do this in 2 ways, but the way that I'm going to do it is I want to have the list that is returned by filter and print that list. That essentially means that my lambda expression needs to be the other way around. So it needs to be, my lambda expression needs to be is even, because all the even numbers, sorry, all the odd numbers are then removed, and those I can print. So break it down in steps. 1, create a main method, easy. 2, create a list of integers containing the numbers 1, 2, 3, 4, 5. And step 3, call the filter method using a lambda expression and print the result. I remember from this question, you can get 2 points from creating a main method and creating the list of numbers. You don't even have to create the lambda expression and you can already get 2 points. So quite easy, create a list, add the numbers 1 to 5. Then we know that we have to do some fancy Java code with the lambda expression, and then we have to print the output. So with the input.addAll, if you do it one by one, so input.add1, input.add2, input.add3, and so on, that's fine as well. I just used the quicker solution here. You don't have to know this solution. Now, for the fancy Java code, we know that we have to call the, we know the return type. The return type is if the input list is a list of integers, the output list is a list of integers as well. We know the filter method takes 2 arguments. The first one is the predicate, which is the hard part, right, the lambda expression, and the second one part is the input, easy part of the function. Now, I kind of did like an extended way of doing the lambda expression just to make sure that it's very clear how I got to this. So this might be explaining, like this might explain too easily for you. I'm sorry, I just wanted to make it as clear as possible. So we know the interface predicate, right, with the one function, the Boolean test. Now let's look back at how we did the comparator, right? So with the comparator, that also has one function, compare, except that this one has 2, well, first of all, it's of an integer, not a Boolean, and it has 2 input arguments. But the structure is exactly the same. So if we would do it with an anonymous function, this would be the anonymous function that we would add. We would get this function Boolean test, and we would return I, the input element, modulo 2 equals 0, to check if the number is even. Now we can simplify that to a lambda expression using the following command. And then look at basically the similarity. We have the input argument I, the return type I modulo 2 is 0, and that's the same thing that we have over here. Okay, let's look at the questions. Okay, so they just want to see that we know how to remove. Yeah, exactly. They do it for, well, I mean, it's called a filter method, right? So what do you expect a filter to do? You expect it to let some things go through and others don't. So in a sense, it makes sense, but yeah, they probably want to see that you know how to use the filter method. Now, to the next part. Oh, and I also remove the warning sign and take a sip of my drink so people can come back in. And then I'm going to go into the design patterns, sort of. So the last couple of exams that I've seen, there were essentially 4 types of questions. One, there was some sort of like general knowledge question, as in the question with the generics that I just showed you could be one of those questions. There would be a design pattern question. There would be a JavaFX question, and it would be a concurrency question. I'll get into the JavaFX and concurrency into a little bit. Now, design patterns is something that you probably haven't really seen during this course anymore. It's a weird one because they sort of tend to it in the lectures. They also give you one assignment in the shape of the visitor pattern, I believe, but they still put questions about it into the exam. So long story short, I don't know if there will be a question about design patterns in the exam, and for that reason, oops. I added the triangle again. For that reason, I'm not going to jump into the design patterns right now. If you all massively want me to explain it or explain the individual design patterns, or especially the ones that they would ask at the exam, so the visitor, decorating, and strategy pattern, I would happily do so at the end. That being said, I linked videos to each of these buttons, so you can essentially see a guy who can explain it way better than I can, and it's on YouTube. It's free. You can look it back. You can watch it 5 times if you don't understand it the first, second, third, and fourth time. So I'll leave those here. Again, if you want me to explain it as well, sure, no problem. Just let me know. And that's all that I'm going to do for design patterns. So essentially give you YouTube links. How easy can a workshop be? Streams. Most of the time there is one stream exercise that basically consists of 2 sub-questions, so like 1A and 1B, where you have to create streams. I think the most important thing is understanding the concept of streams, and then take that into the exam and basically know what these 5 to 6 things, what they do. So I'm going to give you an example, explain very briefly what each of them does, and I think that should be enough for you at the exam. So what are streams in general? Streams in general are just another way to loop through a list and do something with that list. Sounds very vague. It's also because you can do quite a lot of things with streams, and what you can do with the list depends on the type of stream that you're using. So you always start with the list.stream. So I have now an input list of integers 1, 2, 3, 4, 5, and I'm going to be using this one the entire time. Let's say that I want to add 5 to every element in the list. What I do is I say list.stream, essentially how I start a stream, .map, and then you always use this lambda expression notation. What this looks like exactly depends on 1, the type of streamer that you're using, 2, what you want to achieve with the stream. But map allows you to perform an operation on every single element in the list, which means that you basically visit every element in the list individually. So that means that you have 1 element over here, 1 element that you're visiting, and for every element I want to add 5 to the element. And basically what this last part means, this dot collect collectors to list, basically means that, okay, I added 5 to all the elements, and now I want to return it back as a list. So basically, that means that I can store it into new list. If I now print it, you can see that it has 5 added to every element in the list. So 6, 7, 8, 9, 10. Map function. Reduce function. So the reduce function allows me to basically small down the list to a single value. So let's say that I have my list of elements again, and I want to use the reduce function to calculate the average of the list. What I can then do is I want to use my reduce function to add all the numbers together, and then I'll divide at the end, because division is not something that I think you can do with streams. Might be wrong, but this is anyway just an example. So you say again list.stream, how you start up a stream, dot reduce. The 0 is the start value. Now you have A and B, because it wants to know with every pair of elements that you have in the list, what do you want to do with that pair? Well, in this case, we want to add them together. So first, it's going to see 1 and 2. We're going to add those together. It will be 3. Then that 3 and 3, what do we want to do? We want to add them together. We have 6. That 6 and that 4, what do we want to do? Add them together. We have 10. That 10 and 5, what do we want to do? You want to add them together. We have 15. Yes, that's correct. And then I added this divide by list.size, so divide by 5, and then we arrive at this 3. But the most important part is this reduce function. You can also do like minus here or division. The thing with the reduce is that you can do multiple types of operations. As opposed to the sum method, the sum method can only be used, as it implies, to sum up all the elements in the list. So you have a default stream. Now what you have to do, you can only apply the sum on something that's called an int stream. So we have to make sure that it's an int stream. You can either do that by calling int stream over here instead of regular stream, or you can do that by mapping to int, basically meaning that you ensure to the stream that every element is of the type integer. And then you can call the sum, and again, I added the list.size here and printed it out. Are you missing some brackets, reduce page, or is that how you write them? Am I missing brackets? I think I'm not missing brackets. Like I have an opening, like here I have an opening and closing bracket. I have an opening and closing bracket. Yeah, no, this is. Oh, yeah, okay. What might be a bit confusing is that you have two input types here, or two inputs here. You have the 0, which is the start number, and you have the A and B. And that A and B is seen as a single input. So that's why that A and B over here is also in brackets. So that might be the confusion with the brackets. But it is correct. Next, the filter method. So as you can possibly guess, the filter method is used to filter out elements that do not match the specified condition. So let's say that we want to remove all the odd numbers, or that we want to keep in all the even numbers. So filter also drops by every single element in the list. So it doesn't have like an input pair. It has a single input. And then what do we want to be the condition for every element? Well, element modulo 2 is equal to 0. And then collect it again in a list, because the return type needs to be a list. Is the first argument of the reduce a value or an index position? Good question. I think it's a value, because I know that if you use a reduce where you want to multiply the entire list together, you have to start with a 1, because if you start with a 0, then the result will be 0. So I think that the first element is the starting number. Because if you would use the multiply and you would multiply by 0, then obviously it would be 0. but something that I could test later. But I'm quite sure that it's the starting, it's the start number, essentially. Filter, and then lastly, the sorted, and the sorted, as it also implies, is a way to sort a list. Again, start with the list.stream. Now, how it works over here. So here you have basically A and B, 2 input arguments. Again, it's the same thing with the sort method that we saw before, but how sorting in Java works is it constantly takes 2 values, compares those 2 with each other, and then either flips them or leaves them the way they are, depending on the values. So that's why you constantly have 2 values in sorting. And it is the same thing where if they're equal, you return 0. If one is larger, you return -1, and if the other one's large, you return 1, or essentially larger than 0, or lesser than 0, which is why B minus A works as well, because it doesn't matter if I return, for example, -5 or -1, it still implies the same order. And here you can see that the input or the output is the reverse or the inverse of the input list. And I can see, yes, it is indeed the starting number. Thank you. On to JavaFX. Now, with the JavaFX. JavaFX is essentially the most scary part of the exam, especially because you don't have an IDE, I believe. I think you have to do it in Cirrus, and I think that Cirrus just has text boxes and that you don't have an IDE. I do see one question. So does that mean the first pair reduce method reduces is the input value plus the first number in the list? Yes, that's correct. Yeah, exactly. So it starts in this case, it starts with 0 and 1, and then it adds those together. That's 1, add 1 and 2, and yeah, and so on and so forth. Yeah, exactly. So with the JavaFX, I did not put that much information about JavaFX in the slides because I was sort of expecting to, so when we're in the question round, that I'm going to open up my IDE, and for the people that want to see specific things about JavaFX, that I'll just show it, because it's kind of hard and unpredictable what to guess what people do not understand about JavaFX or what parts are difficult about JavaFX, because I feel like everything's just difficult about JavaFX. So anyway, the most important parts that you have to know about. 1, properties. Properties basically are ways to bind values to each other, which is a very vague way of explaining it and something that explains nothing. But it essentially means, let's say that we have 2 variables, a variable A and a variable B. If A changes, then B automatically changes as well. And B is automatically updated that A has changed, and then B does something as well. I'll get to an example in a little bit. Listeners. Listeners are it's essentially it's very similar properties, so it's hard to kind of differentiate. But listeners are essentially what happens when an element changes. So, better example. Let's say that I have a Boolean, and that Boolean changes from true to false, or something changes that Boolean. You can add a listener to that Boolean, which is essentially something that listens to changes to that Boolean. So whenever that Boolean changes, the listener is getting notified and being told, hey, the Boolean that you're supposed to listen to, it just changed. You might want to check it out. Then we have the timeline. The timeline is an interval function. So what I mean by that is you can use the timeline to basically make periodic changes. So let's say that you have a snake, for example, you have the snake assignment, right? So you had a circle at some point, and then the circle moved the spot, and it moved the spot, and it moved the spot, and it moved the spot. And it did so at a very regular interval. And that's something that you use a timeline for, to basically ensure, okay, this change happens every 500 milliseconds, for example. And lastly, we have event handlers. Basically, event handlers are specifications about what you have to do when an event occurs. Now, what are events? Any keyboard presses or any mouse presses, those are considered events. So for example, you can add event handlers to the mouse and the keyboard to basically say, okay, what has to happen when the mouse is moved, clicked, dragged, thrown out of the window, and what needs to happen when I press the button on my keyboard. Now here, so the observer pattern. Yeah, listeners are, you could see listeners as the observer pattern. They kind of replaced the observer pattern in Java. The observer pattern, as far as I know, is just not really a thing or not something that we call it anymore in Java. But don't quote me on that. I just haven't seen it in a while. So properties. Let's say that we have a rectangle, which are the gray things, and let's say that we have a text field over here. Now what we want to have is that the height of the rectangle is the value of that is in the text field plus 10. So if the text field says 50, then the rectangle will be 60. If we change the text field to 90, then the height of the rectangle will be 100. Now, in order to achieve this, we need 4 things. 1, we need an input text field. We need a rectangle, and we need 2 properties. I see the question, what's the difference between a text field and a label? A text field you can write text in, a label you can just display text in. So you cannot edit the text that is in a label. That's the difference. So we need a text field, a rectangle, and we have 2 double properties. So the double properties are for the input. So the input is we're going to bind this input to the text field because we want that value, right? The text field, what's important to know about the text field is that it's always a string, while a rectangle or the height of a rectangle is specified by a double. So we need to convert that string that is in the rectangle, we need to convert that to a double to make sure that we can do math with it, because we need to add 10 to the input value to get the height of the rectangle. And then we need a height value, and that's for the reason that I just explained. The input double property is going to be equal to the value in the text field. The height double property is going to be equal to the input property plus 10, because that's what we want to achieve here. So this is actually, okay, I'm going to show this one, the second line first, and I'm going to dive into the second line first before I'm going to digest the first one. So these are the double properties that I talked about. So I said the height of the rectangle needs to be whatever is in the input field plus 10. How binding pretty much always works, or most of the time works, is that you put the dependent variable at the start. So height is the one that needs to listen to changes of the other, dot bind, and then you put the value that it's listening to in the brackets. So input being the double property, and now you can, for example, say dot add 10. It adds, basically height is whatever the input is, plus 10. There is one example, which if you don't have a cheat sheet, if you're not allowed to have one, you're going to have to memorize it. Unfortunately, if you do have a cheat sheet, this could be on there. The one exception where you practically for the O exam need to switch it around is with input field and with text fields and double properties. So I said that the input is the double property input is whatever the value in the input field is. So you would say that it then would be input.bind input field. This is something that doesn't work because the input field, the text field, is a string or a string property. The input here is a double property, so we have a type mismatch. It doesn't work. So we need to convert whatever the value of the input field is to a double. Essentially, long story short, this is just how you bind a text field to a double property. I would just memorize this and make sure that that's something that you know by heart for the exam. Then lastly, we want to bind the height property of the rectangle to the double property height. So that means that if the height double property changes, then the height of the rectangle changes as well. I don't have any live JavaFX demos. Again, if people want to have more information, stay until the end, ask me more questions at the end, and I'll happily show you. Example of listeners. Oh, I actually put in the Boolean example. Let's say that we have a Boolean property. We call it some Boolean. We can add a listener to that Boolean, and then whenever this some Boolean changes, this listener is triggered, and we can just put some code into the brackets here and do whatever is necessary. This, again, it's a lambda expression, and it has 3 parameters. First one, observable is not, I don't actually know what kind of information is in there, so it's probably not important. Then it has the old value and the new value. So, for example, we can say if new value, so if the new value is true, we can say Boolean is true now, shock-faced. Now, for the timeline, also with the timeline, it's just that the notation of the timeline is something that you just have to remember. Timeline is new timeline. The 2 things that are important for you to know is that duration.millis. Here you put in the interval, and that's in milliseconds. So this would be every 500 milliseconds, every half a second. And some function, you have to replace some function by whatever function you want to call with the timeline. Then you always have to do timeline.setCycleCount, timeline.indefinite. If you don't put that in there, the timeline will only run once and then it will stop, which is not what you want from the timeline. And then you have the play method and the pause method that you can use to either start it or stop it. Okay, event handlers. Yeah, like I said, they are to register essentially or know what to do when you have mouse or keyboard events. So root.setOnKeyPressed, that's going to activate or be called whenever I press a key on my keyboard. And if I then, for example, want to know, oh, and it always has this layout of variable name, arrow, and then some function. And if you want to see what key I pressed, you can use key.getCode. Again, this is also something that's quite useful to just memorize. And same thing for the setOnMouseMoved. If you want to have the coordinates of your mouse, you say e.getx and e.gety to get the mouse coordinates. What I did in previous years is that I actually coded up one of the old exam questions. Again, I'm fine with doing that later if people want to see it, or alternatively, here's the solution. Point is, this is one of the old exam questions. This was, I think, even before they started using net, or we had a couple of years where we had NetBeans at the exam. I think this was still when the people had to write it on paper. So like, I have no idea what they're going to do, or if they're going to take into account the fact that you don't have an IDE at the exam. You can expect some similar exercise to this, or just look at old exam exercises that they shared with you. And again, if you want to see a solution, just click on this button. Will our JavaFX question be as difficult as this? Because this seems very complicated without IDE. Short answer, I don't know. Long answer, it could be, but I don't think so. What they did with the last JavaFX exercise that I've seen is that they split it up into different parts. So for example, with part A, you just had to implement the double properties. With or at part A, yeah, question A, you had to implement the double properties. Part B, you had to implement this. Part C, you had to implement that. What I can say is that with JavaFX, generally they already give you the layout, so you don't really have to know what panes there are. For example, right? You have like a grid pane, stack pane, a regular pane, a V box, horizontal box. If you see one, you kind of have to recognize it, but you don't have to know them by heart and know how they work. You don't have to know, for example, how to add padding or colors. Well, actually, colors maybe, but you can see that over here that they give you a hint about how colors work. Long story short, I don't think so. I don't think it will be as difficult as this. Don't quote me on that though. It might be. And even this assignment actually isn't that difficult if you just take it step by step. And that's the most important part. Like, for example, I can show you, again, I can show you later if you want, but the way that you can approach this assignment is, okay, let's first, for what you have to do is that if you move your mouse over the screen, the line is following your mouse and there's a ball at the end. If I click, a ball is added halfway during the line. If I click again, another ball is added. And every ball that's being added, the moment a ball is added, all the balls distribute evenly across your line. So this is an assignment that you can build up very well. So first you click once. Okay, or first you make sure that the mouse that you know how to add a circle. Then you add then you add a line, right? And then you add, okay, the circle and line should follow my mouse. Okay, now let's add a circle when I click. Okay, perfect. Those are all relatively easy things to do. It's just that adding it all together makes it quite a big exercise. So it's not that hard if you just break it down very well. And those are like those small steps, how to create a circle, something you can memorize. How to make a ball track your mouse, something that you can essentially memorize, right? Because you can memorize this root.setOnMouseMoved and then use the e.getX and the e.getY to set the center of the circle. It's just that you have to know the functions that exist in JavaFX. But those are things, again, that you can memorize. So that was a way longer answer than it needed to be, but there you go. Into the final part of my workshop, which is concurrency. As you know, Java, or as you've mostly used programming languages are generally sequential, which basically means they work top-down, they work one step at a time, they don't have multiple processes going on at the same time. With concurrency, you can have multiple processes going on at the same time, which is very good if you want to speed things up to a certain extent. Basics of concurrency. So this should not really be anything new for you because you've had concurrency in the last couple of weeks, but just a very quick recap. Things that you want to run simultaneously, you let implement runnable. And here I created a count runner that, I'm sorry, by the way, I have like hay fever going on, so my nose and eyes itch like crazy. I made a count runner basically that counts from 1 to 10 and it gets a name. So for example, this one, it has to count from 1 to 10 and it basically has to print name says and then the number. If I would run this without concurrency, so not using threads, it would be, and I would run two count runners, then it would do one count runner first and then the other count runner second. What would happen if I do use concurrency? This. So I created two threads, one with Chuck, one with Paul, Easter eggs for your teachers, and basically they run simultaneously. Sometimes you can see like this going on where Paul says a number like two numbers at once, but essentially that's how threads work. You work in parallel. It should be nothing new. What the exam question is most likely going to be like is something to do with synchronization. Synchronization is the thing that you saw in the last two exercises, I believe, where there are multiple processes going on, so multiple threads running, that are interacting with one and the same object. So in the assignment 14, it was the train station, right? So you had taxis and trains all dealing with the same train station. With the last assignment, it was the conveyor belts, or I think it was the conveyor belts where the cashier and the what was his face called? The customers were putting things on the conveyor belts. I don't remember the assignments correctly because it was like a year ago, but it was something like that. Concurrency is essentially the part of the exam where it's easiest to score points, because with concurrency, up until this point anyway, there's a very simple recipe that you can follow, which is essentially this recipe. First step is determine the shared object and give it a lock. Then with the shared object, ask yourself who has to wait for what. And a couple more points, which I'll just show you immediately in the shape of an example. So this example could, as far as my experience goes, this example could be an exam question. So imagine we have a restaurant with a buffet. The guests can only grab food from the buffet when there's still food left. And the number of food that we have is an integer. So we don't specify what food it is. It just says we have 1 food, 10 food, 15 food. The kitchen can only add food to the buffet if there's less than 10 food left. When the kitchen adds food, they add until the buffet is full, which is 30, and guests grab a random number of food between 1 and 5, and 1 and 5 included. So first question, normally I would yell this into the classroom. Now I'm not going to wait for your answer, but the question would be, what is the shared object? So the shared object in this case is the buffet. So the first part was determine the shared object and give it a lock. So we know that we have this class buffet, and we know that we have to give it a lock. Okay, perfect. Step 1 complete. Then with the shared object, ask yourself who has to wait for what. And that basically tells you the number of conditions and the situations that the conditions are being called. So who has to wait for what? Well, the guests have to wait if there is not enough food left. So if I want to grab 5 food and there's only 3 left, then I have to wait. The kitchen has to wait until there's less than 10 food left, because they can only add food if there's less than 10 food. So there are 2 situations in which I have to wait, which means 2 conditions. Now, note that what people find naming the conditions very confusing. So I named them add food and grab food. If you just want to call them A and B, that's fine as well. I've seen both ways, because the names of the conditions can be quite confusing. Then what I generally do is add variables to the shared object class if the assignment states specific variables related to the shared object. And what I mean by that is that the kitchen can only add food if there's less than 10 food left. Okay, that would sound like a number to me, a variable, and the teachers don't really like it if you put those numbers in the while loop themselves. So sometimes we even have to deduct points for that. If you don't use variables, we have to deduct points. So I added private final integers, threshold, and capacity, because the kitchen adds food until it's full, and the capacity is 30. And then I also added an integer, which basically is current amount of food at the buffet. Next step, implement the methods in the shared object class and make sure that the methods throw the exceptions and not catch them. So the exceptions, very important, also something that you're getting points deducted for if you miss out on them. And then you have this structure, which is basically the same structure all the time, which is you start with the lock.lock, then you have a try and finally, and in the finally you say lock.unlock. Same, and I have 2 methods, one for the kitchen where you can add food, one for the guests where you can grab food, and it gets a parameter int to grab, which is basically the number of food that you want to grab. And I added this note. The interrupted exception is you only have to throw it if there is an await in the if you call the await in the method. Small side note, but you can assume that that's always the case. Okay, next part, we can implement it further. So this is the method for the kitchen, adding the food. Well, when does the kitchen have to wait? The kitchen has to wait while amount is larger or equal than threshold. So if there's 10 or more, we say add food.await. When do the guests have to wait? If this amount is less than the amount that they want to grab. So we say grab food.await. Another thing, always have while statements here. Never have if statements. One final thing that I want to note here is if you only have one line of code in your while statement, same goes for if statements and for loop, you don't have to add brackets. So this is actually valid Java code. I didn't add the brackets here, and that's because I did it at more points during my presentation, but I just realized it. Then for the final part, what does the kitchen have to do when it breaks out of the while loop? Well, when it breaks out of the while loop, it knows for sure that that it can add food. So it says amount is equal to capacity, and it gives a signal to grab food. Basically giving a signal to all the guests that are waiting, hey, we just replenished the buffet, you can grab food again. What happens in the grab function? We deduct to grab, so the amount that the customers want to grab from the amount, and we give a signal to the kitchen, essentially saying, hey, I took food from the buffet, maybe you'll have to fill it up. What happened, and this is the reason why you have to add the while loop, for example. What happens when this add food.signal all is called? This add food.await stops waiting if this were an if statement. So let's say that there's 20 food left and I only grab 2. There's 18 left. I give a signal to the kitchen, hey, I just grabbed food. Now let's say that this were an if statement rather than a while statement, then it would break out of that if statement and replenish the food, the amount of food to 30, even though there was 18 food remaining. So that's why you always have it in a while loop. What you could do is have add food in an if statement. So basically say only call this signal all if there's less than 10 remaining. But generally, this is the approach that I would go for. Oh, yeah, so I get the question now, can we use if statement in the signal all, something like amount less than threshold, add food.signal all? Well, the answer is yes. Yes, you can. It's definitely not bad to do so. Yeah. What I tend to do with these kind of assignments is they also want to, they always want to simulate real life situations. So let's say that I'm at a buffet, right? If I'm at a buffet and I grab food and I walk off and I walk past the kitchen, for example, the kitchen sees me walking with my plate. You could see that essentially as the add food.signal all. Never am I ever going to be in a buffet, yell at the kitchen, hey, I just grabbed food, you may have to replenish it. So that's essentially the situation that I'm kind of picturing in my head. So in that case, the if statement would not make as much sense. But again, adding it would definitely not be bad. They would not deduct points if you were to do it. Okay, then the next part of my recipe is determine and implement the runnable classes. Often the teachers want to see thread.sleep and print in a run. And the run is also where we catch the exceptions. They will deduct points if you do not add a sleep and print. So the sleep and the print, essentially, if you add them to your run method, 3 points. You know, you probably get 2 points for it, but they're free. You know, you don't have to do anything for them. So I only did the guest, by the way. I did not do the kitchen, but you make the guest implement runnable. A lot of code that I added. What they generally also want is for every guest, because there are going to be a lot of guests, they want to have an ID. Then you also need a random, because you need a random amount of food, and you have a buffet. Now, normally I would ask you, why is the buffet into the through the constructor? And I'm going to give you like 1 second to think about it. So why do I pass in the buffet through here? And why do I not say buffet is new buffet? Okay, time's up. Reason is that if I say private buffet is new buffet, every guest would have its own buffet, which, you know, might be an American restaurant, but in most restaurants that I've been to, most buffets I've been to, I didn't have a personal buffet, unfortunately. Then the run method generally has the same layout, try catch. So again, the run is where we catch the exceptions. We have a try catch with a error. Doesn't really matter. Error handling is not too important at the exam. And most of the time at the exam, it will be fine to do a while true. So you always have to do some form of while statement because the runnables have to run for a longer while. At the exam, most of the time, or every time that I've seen anyway, you can use a while true. And then you just implement it in the sense of whatever it needs to do. So it needs to determine the amount of food that it wants to grab, which is a random number from 1 to 5. Then it needs to grab that from the buffet. And then it needs to do a print and a sleep. So these two lines, the print and the sleep, 2 free points. And I see debugging 101, exactly. Okay, then the last part is starting all the threads or create and start the threads, preferably using an executor service. Executor service, there we go. And this is mostly something that you can just memorize. You can also create single threads as I did over here. So here I created 2 new threads, but they would prefer for you to use an executor service. One very important thing is do not, so let's say that they want you to create 20 guests, do not say exec.submit 20 times below each other. They're going to deduct points. Use a for loop. Second point, do not here, rather than number of guests, say 20 here. They're going to deduct a point from that. So make a variable number of guests, make a for loop where you use that number, and you already have 2 points again, probably. And then you can do the exec.submit for every guest. See how I give it an I and a buffet, because it needed to have an ID and a buffet. Finally, I create the kitchen, which I'm also going to give the buffet. I didn't create the kitchen here, but I'm just going to assume that it exists. And I'm going to say exec.shutdown. This works. It's not the perfect solution. The perfect solution would be to use the future. If there is any interest, I will happily explain the future. I'm just going to leave the code here. Futures always look the same in how they work. So I'm just going to leave the code here, and I'm going to go to the next page, which is my questions page. So if people want me to explain how the futures work, I will happily do so. But until then, well, first of all, thank you for listening. And secondly, are there any questions? And thirdly, are there any people who want to see specific things in, are there people who want to stay now and who want to see specific things in the IDE where I can just show, where I can just show random stuff. Okay, I can see, can you explain what is .consume, what are callables, and how do futures work? Okay, then I am going to answer the questions. First, the .consume, absolutely. When you create a lot of threads, essentially you are basically adding, every time you create an object, you are basically reserving memory space, right? With the .consume method, you basically remove it from memory and you make sure that the thread doesn't exist anymore, it doesn't run in the background anymore. So you just free up some memory space. That's essentially what I think consume does. It might do more, but that's what I think that it does. Second question, what are callables for again? And I am going to combine these with the futures. So in my example over here, yeah, for the guests, you can see that my run method, you can see in the run method that it's a void, right? And that's fine. And the reason why that's fine is because the guests have to do something, but they don't have to return anything. Now, let's imagine this situation. So, yeah, just imagine this situation. Imagine that I have that I'm in a room full with people. I'm like the manager person, and every person in that room has a stack of bills, like $1, $2, $5, $10, $20 bills, and every person has to count basically the sum of those bills. You can see every person in that room as a single thread, right? All those people are working simultaneously. They are counting simultaneously. Now, I know that by the end of the day, they're going to come up to me and they're going to tell me, hey, I counted this many bills and that added up to $1,000, $2,000, $1,500. So I know that when the threads are done with running, they are going to give me a return value. And that's where you use callable. So you use callable instead of runnable if the threads are going to give you a return value by the end of the day. But also, that's where you use futures, because when I walk into the room that morning and I tell everyone, hey, you can start now counting the bills, I know that by the end of the day, they're all going to come up to me and they're going to give me their final tally of how much money they counted, right? So the knowledge that they are at some point done with their tasks, and the knowledge that they're going to come up to me and give me the value of which they counted, that is the definition, or that is what a future is. So basically that means that, and so that is what a future is. And then over here you see what how you implement them. The future, you make a list of future called futures. You always have this as a question mark here. The reason for that is that basically, like I said, I know that my people are at the end of the day going to give me an integer or a double with the amount of money that they counted, but that's not that would basically mean this question mark. This question mark means they're going to give me something, and I don't have to specify that integer just yet. So this part you can memorize, how you create the list of futures and how you can add some things to them. Always use the submit method where you're using the futures. Now this last part is how we can get the value of what they actually counted. So f.get is going to give me, for every single person that is done counting his money, it's going to give me the value that they added up together. So that 1,000, that $1,500, that $2,000. The f.get is going to give me that value. So what I could potentially do is I can say, for example, total sum plus is f.get, if I were to do that example where they were counting money for me. What also happened is that we are dealing with threads. So if we're using this method, right after the exec.submit has been called, it will continue with all the code that is afterwards, because we're dealing with threads, right? So they're doing things simultaneously. So when the thread starts running, it just runs the rest of the code that comes afterwards, or after that. When we're using futures and we call this f.get, we won't run into that issue, because that f.get can only be called once the future is done. Or once the runnable is done. Once the future is done sounds very apocalyptic. Anyway, so yeah, once we're past this for loop, we know that all the threads are done. That's essentially it. So that's basically the combination of callable and futures. I hope that is clear. And then, Can you maybe explain how the old/new value parameters work for listeners? I don't really understand how to use them. Absolutely, but I cannot really add much more to that than what I showed you before, which is essentially this part. So whenever you have a property, and it can be an integer property, it can be a double property, it can be a Boolean property, with any kind of property, you can add a listener to it, and that listener is being triggered every time that the property changes its value. Now, every time the property changes its value, this method is called, and then you have the observable, unimportant, you don't have to know what this is. You have the old value and the new value. Now, let's say that we have a double property, right? So let's say that instead of a Boolean property, this is a double property, and the value changes from 5 to 10. So the value changes from 5 to 10. That means that this function is called because it listens to a change of that value. The old value is 5 because it changed from 5. New value is 10. You can then do in here whatever you need to do. This could work, for example, maybe in a video game. I don't know. Some you could then you want to have, for example, if the score changes, right? Or you can use it. I don't know. There are probably many ways you can use it. Video game is the only thing where I can think of now. Yeah. Okay. Yeah, he said, oh wait, I get it now. I was confused because the values were Booleans. Thanks. Yeah, so it can be Booleans. It can also be, it can be doubles. It can be integers. It can be whatever you can make properties of. Yeah. Then also some more things I have. So I am going to share these slides with you, and I think Cognac is going to share them with you, or they're already being shared somewhere. You probably know, but when's the exam? Is it like the 23rd or something? 22nd? Because generally, if you tell me when the exam is, I will keep an eye on this document, so you can add questions to this document, because you're allowed to comment on the document. So you can add questions and I can answer them. Next Wednesday, 23rd. Okay, perfect. So yeah, you can leave questions in this document, and I'll try to look at it every night so I can answer some questions. Then I also had left some extra exercises, some old exam exercises. Honestly, I don't remember what is in here. Probably useful stuff, I would say. And this is from a couple of years ago, where I did another stream where I left some code. Anyway, so there's an appendix with more stuff and also some extra concurrency exercise. Now, do note with this concurrency exercise that it's not necessarily representative, there you go, of what you can expect at the exam. But regardless, it is a good concurrency exercise to do. What would you recommend to put on the cheat sheet? For that, I'm going to go back to this part with the old exam question. So with exam questions, right? It basically consists of two parts. One is for you to recognize what you need to do, right? For you to basically make those steps and make that progressively for yourself. That basically says, okay, first I have to create a list. Then I have to create a for loop, and in that for loop, this needs to happen. And then I need to use an iterator and things like that. That is something that you have to practice. Now, how to actually implement those steps, those are the things that you can put on this cheat sheet. So essentially, I would say most of the things that I put in the slides here can be useful for the cheat sheet in the sense of how do you make an iterator? How do you, for example, like maybe one example of a stream might be useful. Maybe how to create, here, this line, for example, how to bind a text field to a double property. That one might be useful. How to create a listener might be useful. I would just add like small code snippets that basically tell you how to use a function. So for example, this add listener works exactly the same for a double property and for an integer property and for a Boolean property. So if you give the example with a Boolean property or a double property, and you add that to your cheat sheet, then you know how to use a listener in general. So those kind of things. Timeline, I would add timeline to your cheat sheet. Haven't seen them use it in the last couple of years, honestly, but still might be useful to add it. The get x, just like the tiny, very specific coding things that you would otherwise need to memorize. So the get x and the get y for the mouse position might be another one. Here, this step-by-step plan for creating threads, if you find it useful. You know, like some people might not find it useful, then by all means don't add it to your cheat sheet. If you find it useful, do add it. But yeah, I hope that answers your question. Okay, then if there are no further questions, you're welcome. If there are no further questions, then I am still going to ask you, are there people who want to see me do stuff in an IDE? And if there are no replies, then I'm just going to assume that you've asked all from me that you wanted to ask. Some more JavaFX would be nice, maybe. Okay, perfect. Would you perhaps like to see me do this exercise, the beats exercise? And that question is not necessarily representative for any question that you might get, because you don't have to use a text field, for example. But it's JavaFX, and it's more the thought process of how I approach an exercise like that is important, I would say. Okay, perfect. I have a yes exclamation mark and a that would be great. That is enough for me. So then I'm gonna fire up my IDE. Oh, come to think of it, there's actually one thing that I didn't explain whatsoever that might be at the exam, which is, bam, the testing and assert, so unit testing. That will also be at the exam. If people want me to give like a quick example, again, let me know. Then I'll cook up something in a bit. But before that, let's go for this exercise. The way that I'm going to do it now is different than the solution that's over here. So this is going to be an exclusive for you. So write a JavaFX program that makes a string of beats. The program starts with a single blue beat somewhere on the screen. You can choose the initial position freely. This beat is always connected by a black line to the upper left corner of the screen. When the mouse enters the screen, the center of the blue head becomes the position of the mouse. The beat stays centered at the mouse while the mouse moves inside the screen. Well, I kind of explained it before. So every time I click, a new beat is added. The beats are distributed evenly across the line, and the colors of the beats go fade from red to blue using RGB. Okay, I kind of expected this question to come up, so I kind of already prepared it. Let's see. Okay, first things first is, by the way, is everything readable? Like, is the font size big enough? Otherwise, I can adjust it. Secondly, whenever you're using mouse input, so like we are now, right, because we have to use our mouse across we have to move our mouse across the screen and we have to register that input. Whenever you do that, basically you want to use a regular pane, like what you're using over here. We do not want to use a grid pane or a stack pane or a horizontal box or a V box. We want to use a regular pane. Okay. Readability could be better. It's pretty grainy for me. Okay. Unfortunately, I don't think there's much that I can do about that without starting the stream or without shutting down the stream and starting it back up. Let me know if it's too bad. If it's too bad, I'll stop the stream and I'll start a Zoom meeting, and then I'll just invite you all to the Zoom meeting. So if it's too bad for too many people, then let me know. Okay, anyway, we have an empty screen. Beautiful. Okay. Let's first, what I would do here first, so obviously you won't be able to do this at the exam, but in preparation for your exam, what I would do is I would just add a line and add a circle, for example, to the root, just to make sure that you know how to add a circle and a line, right? So I would create a circle and call it circle is new circle, and line is new line. Hold on, I'm gonna do one thing. I'm gonna remove them very quickly from my imports. Now, what is important is that you have to import them, but make sure that you import the right one. And you know that it's the right one if it says JavaFX. If it does not say JavaFX, it's the wrong one. And that can cost you a lot of time before you've discovered that one. So with circle, you can give it a number of parameters. You can either give it nothing and we'll just create a circle without much to it. You can give it one parameter and that's going to be the radius, or you can give it three parameters and that gives it the x position, the y position, and the radius. Now let's say that I want to do that. I want to say put it at 100, 100, and because it's the teachers, let's create a final int radius is 12, and we're going to pass that one in rather than using a variable, then defining variable over here, because the teachers would get mad if you were to define it over here. Same for the line. The line has 4 arguments: a start x, a start x, a start y, and an end x, and an end y. There we go. Now, what happens if I'm going to run this? I'm going to give you about 10 seconds to think of what will happen if I run this, and then I'll show you. Okay, what happens is absolutely nothing. And the reason for that is because I haven't added it to my pane yet. And this is one error that you get a lot and that causes a lot of confusion. So everything that you create, you have to add to your pane. So you can say root.getChildren, which returns a list.add all. And I can add circle and line. Perfect. Okay, now run it again. And I should have a circle and a line. Perfect. Okay, what I would do next is I would try to make the line and the circle move or follow my mouse. There are a couple of ways that I can do that. And the approach that I'm going for now is I'm going to use binding. So regardless, I'm going to have to create an event listener like I showed you before. So this is something that you could, for example, put on your cheat sheet, is how to create an event listener. But the code is root.setOnMouseMoved, because they have to follow my mouse. And it always has the structure E arrow, and then function brackets. Note that this e can be named whatever, as in I could literally name it whatever and it would work. And let's very quickly print whatever. Okay, I'm going to change it back to e because whatever is annoying. E dot get x plus e dot get y, just to make sure that it works. And you can already see, if I move my mouse across the screen, you can see that it prints out the x and y position. So you can see I move my mouse up, you can see the y position getting smaller, and now also the x position getting smaller. Perfect. Okay, there are two things that I can do right now. What I could do is I could say circle dot set center x, I believe, to e dot get x, and the same for y. That would work. Set center x and set center y are functions of a circle that I could use to change the position of the circle. And you see over here, it works. See, it follows my mouse. This is one way of doing it. But you also learned about binding. And binding, I would consider the prettier way of the two. So what you can do is you can create a double property x, let's call it, say, mouse x position is new simple double property. And same for mouse y position. Make sure, oh, whoops. I did not want to create a class, I wanted to import it. Add import for double property, add import for simple double property, there we go. What I can then do is I can say circle dot center x property dot bind, because I want my center x property of my circle to listen to the mouse x property. And the same for the y. So, okay, then I don't need this anymore. Oh, oops, mouse x position, mouse y position, my bad. Okay, I'm going to give you another 5 seconds to guess what will happen now. And now I'm going to show you nothing happens. And the reason that nothing happens is because we do not change the mouse x position and mouse y position. Now, it would be very neat if we could bind these double properties to the position of my mouse, but I don't believe that you can bind to the mouse position. Maybe you can, not that I know of. So if you want to perform a quick Google search, then be my guest. But until then, I would just say mouse x position dot set e dot get x, and the same thing for the y. And now you will see that the circle starts moving again. It starts following my mouse again. And this is through binding. So essentially what happens is that whenever my mouse position changes, the center x property of the circle changes as well. Whenever my mouse y position changes, the same goes for the center y position. If we set the mouse x position and the mouse y position in this set on mouse moved, these double property change, and therefore the center x and center y change. So what I can also do, I can say line.end x property, same thing, dot bind mouse x position, and again the same for the y. And now you should see we have a ball or a circle and a line. Now, this is where the difficult part of the assignment starts, or where, not necessarily where it starts, but where we have a difficult part of the assignment. And that is calculating where the balls need to be. And I would also advise you to just take notes in your code here. Now, let's say, for example, mouse is at 150, 150. So X position is 150, Y position is 150. We have one single ball. What is the location of the center of the ball? Well, it is 150, 150. Let's say that we have two balls. What is the position of the center X, center Y of the first ball? And we go from top left to bottom right. Position of the first ball is 75, 75. Position of the second ball is 150, 150. Let's say we have a third ball. What's the position of the first ball? 50, 50. Second one, 100, 100. Third one, 150, 150. So what you're going to have to do is you're going to have to basically find the formula to calculate the position of the ball. And if you see the pattern, it is position divided by number of balls times index, essentially. So when I'm looping through the list, the first ball is at so we have three balls. The first ball is at position 150 divided by number of balls, which is 3, so at 50, times the index of the ball. So it's actually index plus 1 because it's the first ball, but that means that it's number 0 in the list. Second ball, position divided by number of balls is 50 times 2, which means 100. So this is the formula that you need to have. If you were to run into something similar at the exam, by all means create something like this, or have like a couple of examples that basically help you create a formula. What this does tell us though is that we also need to have the number of balls. So what I am going to do is I'm going to create a list of circles, and I'm going to call it beads, is new linked list. I'm actually surprised that no one today asked me what's the difference between a linked list and an array list. Oh, oops, that's a list of circle. And we are starting with a single circle, so I'm already going to add this circle to the list. Beads dot add circle. Okay, perfect. There we go. I'm going to create this one up here, just reorganizing my code a little bit to have it all pretty. Okay, there we go. Well, what's the difference between an array list and linked list? I should have seen that one coming. Difference between array list and linked list is basically the way that that Java reads and writes from the list. I don't know which one is which, but an array list is better for reading, and a linked list is better for writing, and that's just because of how Java executes it behind the scenes. It might be the other way around, and there might be more differences, but in practice, for you, there is no more differences. But yeah, that should be the difference. Okay, last part of reorganizing the code. Beautiful. But would you recommend to use a linked list in all code? Not necessarily. I always used to use an array list, and for some reason I switched to a linked list. It honestly really doesn't matter. Okay. Anyway, back to our code. I reorganized everything a little bit, but it still does the same as it did before. Now, something needs to happen when we click. So when we click, we need to add a ball. We set on mouse clicked this time, E arrow. So we still can use the same e.getX and e.getY to find the position of where we clicked. So let's just to test, let's add a circle to the pane at the position that we clicked at. So we say circle C is new circle, and we say e.getX, e.getY, and we say radius. Perfect. Now I'm going to say root.getChildren.add C, and this should add a circle at the position that we click at, whilst the other one still follows. And I click, and you can see, perfect. I can leave circles everywhere. Beautiful. Okay, now here we have to do the fancy part, because we can add the circle, but we now have to add it to the line essentially, right? We need to have the positions. We need to do the positions properly. So what we can do is we can add it to the list. We can say beats.getChildren. Sorry, not beats.getChildren. Beats.add C. So we add it to the list, and now we have to do the binding, right? Because all the balls that are, or all the circles that are attached to the list or attached to the line need to be binded properly. How do we do the binding? Well, we do that with this part that we wrote here. So we said that we said that it needs to be at position divided by number of balls times index plus 1. Okay. But how do we find the index? Now I'm already gonna spoil this, but what we have to do is we're gonna have to rearrange the binding of all the circles once we add another circle. What will happen otherwise is this. If we say c.centerX_property dot bind, and we say mouse mouse x position dot divide beats dot size. There we go. And we do the same thing for the mouse y position and the center y position. What we now see is that we can add circles. See, this one works, but if I click another time, the first ball that we added, or the first circle that we added, doesn't change position. So the new ball gets added in the right position, but the other balls, I keep saying balls, the other circles don't transfer their position. And it makes sense because we are binding it using the beats.size, and the size hasn't changed for the other beats, because we cannot use a size property or anything. So what we have to do is we have to rearrange the binding for the entire list of circles. So for int I is 0, I smaller than beats.size I plus plus, and now we have to say beats.get I.centerX_property dot binds mouse x position dot divide, and then we need to divide it by beats.size, and lastly we need to do a multiply I plus 1. That's a whole mouthful. Same for the center y position, mouse y position, and I'm essentially just implementing this formula that I found earlier. Now if I run this, it should work. I add 1, I add 2, I add 3, I add 4, and so on and so forth. For the final part is that what I also need to do is I need to recolor every ball or every circle again in a list. So it needs to go from red to blue. And how I can do that is I can say beats.get i.setFill. You can use the setFill method to change the color. And you can say color.rgb, and now here add 3 numbers. For example, if I say 250, 255, because it ranges from 0 to 255, 0, 0. And then you need to import color. All the balls are going to be red. Or all the balls that I add anyway. Yeah, there you go. Every ball is going to be red. So we need to determine what our R and what our B value going to be, because green is always going to be, because that's what it stands for, red, green, blue. Our G, our green, is always going to be 0. So we need to determine our R. We need to determine our B. Int R is, well, let's set it to 0 for now. Okay, our R needs, so it needs to go from blue to red. So our R needs to get less every time, and our B needs to get more every time. So this needs to be 255 minus 255 divided by beats.size times I plus 1. And I'm just going to leave that here, and you can figure out why this works. And for blue, it's the other way around. So the first one is black. I have to change that. Yeah, there we go. You can see that it's beautiful transitions from red to blue. Final little detail is that the first circle that I create, I know that you can, I think, yeah, I can give 2 arguments, a radius and a color. So I can say color dot blue. And now the first circle is going to be blue. And if I add them, they become more blue. There you go. So that's the beats exercise. It's actually not that much code if you look at it. But still, the fact that they did ask this at the exam is quite far-fetched, right? It is a bit extreme. Is this all clear? Or I hope this is all clear. If not, please let me know in the comments. Okay, well, no response, so perfect. Okay, yes, thank you so much. You're welcome. Yeah, and I think unless there are more questions, I'm gonna give you a couple seconds to ask any questions if you want, and if not, then I'm gonna call it a day. You are all very welcome. Yeah, I'm glad that I could help. If I helped in like any tiny bit, I'm just happy. Like I said, I'm gonna have this document, my presentation. I'm gonna have this document, this presentation that I'm gonna share with you. Or Cognac should have it shared somewhere already. I see one more comment that I'm going to address, which is, it is clear, but if I have to program this without an IDE, it is going to be hard. I get that. However, if you, when I graded the exams, even if your code wasn't perfect, we would still award you points. So for example, let me fire up my IDE. Let's say that I wanted to add a circle. Or let's say that that I wanted to have center X property. Well, you're not going to have an IDE, so it doesn't tell you what the center X property, that this is called center X property. So if you just do something like beats.get I dot X property dot something, you know, as long as we see that this is your intention, you're already getting the points. So you don't have to write perfect code as long as you show that your intention is clear. Or what you could even do is you can write something like, I want to bind it to the position of the ball, but I don't know name of property. And then make sure that if you add this and you use the X property like this, that's fine. You're already going to get the points for that, because the teachers, they want you to pass, right? The teachers, they are lenient in the sense of, if we see that you have the right intention with writing your code, you're going to get awarded points. So if you have the X property like this, you're going to get full points. So yes, I get that not having an IDE is very scary. I know that not having your autocomplete, where it gives you the suggestions and stuff, right? The beats.get, well, it's not giving me suggestions now, .center. It's also not giving, okay, my autocomplete doesn't work now, but I get that not having your autocomplete is scary, or scary is frustrating and annoying, but as long as you make sure what your intention is, you should get away with a lot of things. I think theoretically you can ace this exam without working any functional code, as long as you show throughout the entire exam that your intentions are good, that you know what you're doing programming-wise, but you just don't know the syntax. Anyway, that's the last thing that I wanted to address. It's 11:08 p.m., so that means that I've been going for over 2 hours, which I feel like is a good moment to stop this stream. So thank you all very much for listening, for paying attention, for your questions. Good luck, and if you have any questions, my email address is on the presentation, and just leave comments in the documents, and I will see to them as much as possible. So thank you very much, and I'll see you maybe next time.